All right, welcome to the next section of Calculus 3, where we're going to mainly be dealing with vectors. And basically, what a vector is, or the term vector, is used by scientists to indicate a quantity such as displacement or velocity or force that has both magnitude and direction. Again, magnitude is going to be basically the speed that we're dealing with, and the vector is going to show us the direction in which we're going. And so here's like a little YouTube clip. If you want to click on it, it's just a little funny thing of Despicable Me. Again, you don't have to click on it to watch it. But so we're going to be dealing a lot with vectors in Calculus 3. And when we're going to denote a vector, we basically do that by printing a letter in boldface or by putting an arrow above the letter that you see here. We say that u and v are equivalent or equal, and all we need to write is vector u is equal to vector v. And the zero vector, denoted by 0, has length 0 and is the only vector with no specific direction. So here you see two vectors. We have vector v and we have vector u. You can see that they are equivalent, so we could set those equal to one another. When we are adding vectors, what we're going to do is, if we have two vectors, say vector u and vector v, positioned so that the initial point of v is the terminal point of u, then we can do the sum of u plus v, and that is the vector from the initial point of u to the terminal point of v. So vector sums is initially, if I do u plus v, I'm going to start here with my initial point, and then the terminal point, so where vector u ends, is the initial point of vector v. Then the initial point of u to the terminal point of v is the vector sum. So that's the sum of vector u plus vector v. There's another way to construct the sum. And usually this is not done a lot, but if you place u and v so that they start at the same point, then u plus v lies along the diagonal of the parallelogram with u and v as sides. Then it's called the parallelogram law. This is what we have over here towards the right. And so here you can also see the commutative property of vector sums. So the order really does not matter. We're still going to get the same vector length if we do v plus u or u plus v. All right, so for example 1, we're just going to draw the sum of the vectors a and b. And so taking vector a and adding it to vector b, I'll just write a plus b. And I'm going to start with a. And so our initial a, there's my initial point for a. And again, you're going to try to do this as best you can. You're not going to be perfect. So we're just going to label that a. And then we have vector b. Label that b. And then the sum of these two vectors are going to be the initial of a to the terminal of b. And that's going to be a plus b. And there's the solution.